12-6, circular and periodic functions. Essential question, can I evaluate trig functions based on the unit circle? Can I graph the functions y equal to sine of x and y equal to cosine of x? Here is the new vocabulary. We're going to be talking about a unit circle. A unit circle is where the radius of the circle is 1. When we draw a triangle in a unit circle, the hypotenuse will be 1. And so when we look at the relationship in a triangle, say for instance cosine, the cosine will be the adjacent, which is called x since it's along the x-axis, over the hypotenuse, which is 1. And this shows us that the x-coordinate is really the cosine of x. And when we look at the trial again and look at the opposite over the hypotenuse, and that will say the sine of that angle is the opposite over the hypotenuse. Since the hypotenuse is 1, we say the y-coordinate is the sine. Okay, so if we looked at this point, this is the point location 1, 0, and it's also the 0-degree angle. We say the cosine of the 0 is 1 because that is the x-coordinate. The sine of 0 is 0. If we look at this location is 0, 1, and the angle that's being made is 90 degrees from the initial. So we say the cosine of 90 is the x-coordinate, which is 0, and the sine of 90 degrees is the y-coordinate, which is 1. So here is our definition. Wherever a point is on the unit circle, the x-coordinate is viewed as the cosine of theta, the y-coordinate is viewed as the sine of theta, where theta is the angle being made by the initial and the terminal side of the angle. Let's take a look at a point on the unit circle. I wanted to show you that it was actually on the unit circle by using the Pythagorean theorem to show you that the radius is 1. So we say that the cosine of theta, and the angle being made right here, is equal to the x-coordinate, which is √7/4. And the sine of theta is equal to 3/4. Okay, this point is located right about here, and the x-coordinate is √15/4, and the y-coordinate is -1/4. So we say the cosine of theta is the x-coordinate, which is √15/4, and the sine of theta is equal to -1/4. Let's go to our 30, 60, 90 triangles, and these were the ratios that we worked with. Let's make them into a unit circle by making sure that the hypotenuse is 1. So I'm going to divide by 2, divide by 2, divide by 2. So now I have a unit circle. So here's 1. And the long leg is √3/2. The short leg is 1/2. So this location point is √3/2, and this is 1/2. So that says that the cosine of 30 is √3/2, and the sine of 30 is 1/2. Now if we make the angle 150 degrees, meaning the reference angle is 30 degrees, then the x-coordinate will be the long leg, which will be -√3/2, and the height will be 1/2. Notice how these change. The x-coordinate is the only one that changes. The y-coordinate is the same. So we say the cosine of 150 is -√3/2, and the sine of 150 is 1/2. If we make the angle 210 degrees, and again the reference angle is still 30, we're still working with that same 30, 60, 90 triangle. The long leg is -√3/2, that x-coordinate, and the height, or the y-coordinate, is going to be -1/2. Why are they both negative? Because they're in the third quadrant. -√3/2, -1/2. If we make the angle 330 degrees with, again, a reference angle of 30 degrees, this point will be √3/2. The long leg is along the x-axis, the short leg is along the y-axis, and that's going to be -1/2. So this will be √3/2, and this will be -1/2. Now let's work with, again, a 30, 60, 90, but this time the x-coordinate is going to be the short leg. So again, let's divide everything through by 2 so that we get these relations here. and our short leg will now be 1/2, and our long leg will be right here, that vertical side, which is root 3 over 2. So this will be 1/2, the x-coordinate, root 3 over 2. Now this one, we're working with the same triangle. It's the mirror image, and the coordinates will be, the only thing that will change is their sign. So the x will be negative, and the y continues to be positive, and then we can read cosine of 120 as negative 1/2, and sine root 3 over 2. Okay, again, we just have to worry about the sign. This is going to be a negative. This will be a negative for this angle right here, going 240 degrees. So this will be negative 1/2, and this will be negative root 3 over 2. They're both negative because they're in the third quadrant. Over here, we're going to be using these same points. We just have to watch the sign, whether it's negative or positive. This will be a positive, and this will be negative. And now we'll be able to say the cosine of 300 is 1/2, and this will be negative 3 over 2. Let's now work with a 45, 45, 90. We've got to make a radius of 1, so we're going to divide everything by root 2. And we like to rationalize, so this will be root 2 over 2. This will be root 2 over 2. So the x-coordinate and the y-coordinate are exactly the same, root 2 over 2, root 2 over 2. So this will be root 2 over 2, root 2 over 2. Now, when we go to 135, this will be a reference angle of 45 degrees. It's the same numbers, we just have to change whether it's positive or negative. And what's going to happen is the x was going to have to be negative. So this answer will be negative root 2 over 2, and this will be positive root 2 over 2. Remember, in this quadrant, same thing, but both of them have to be negative. And when we go over to here, it's going to be the mirror image across here. The x will be root 2 over 2, but the y is negative in that quadrant. And so we're able to fill these values out very quickly. Really, it's all about 1/2, root 2 over 2, and root 3 over 3. All our special triangles are there. So if we look at this first one, this is the first one we worked with. Remember, the long leg will be the root 3 over 2. The short leg is 1/2. So you are able to get your points here. Now this is the 45, 45, 90, and that's the root 2 over 2, root 2 over 2. And over here, this is the 30, 60, 90. Remember, the short leg is the x-coordinate, so this is the 1/2, and this is the root 3 over 2. And again, all of these, once you get this first quadrant, all of these are just reflections, and all you have to do is change either the x's or the y's or both of them to get them. Okay, identify the period of a function. We're going to be looking at that in the future. So it looks like this is repeating itself. And so it starts down here, goes up, goes down, and then goes up again, and then it starts the procedure all over again. We say the period is the length of time or the length that it takes to repeat itself. So we say that the period here is pi thirds. In pi thirds, it starts repeating again. In this particular one, I'm starting here, and I'm starting again, so it goes up and then down. So this looks like it's starting all over again, and so we say the period is pi. So that's what it takes to start repeating again. All right, now let's take a look at this without angles, but in radians. You know that pi 6 is the same thing as a 30-degree angle. So again, we're working with a 30, 60, 90, but let's now work with pi 6. The long leg is along the x-coordinate, so this is root 3 over 2, and this is 1/2. This is what we would have used for 30 degrees. Pi force is the 45, 45, and so it's root 2 over 2, root 2 over 2, and pi 6 is the 60 degree, and the short leg is right here along the x-axis, that's 1/2, and then this is root 3 over 2. So what we did with degrees, we can do with radians as well. Okay, so let's take a look at evaluating. Like, evaluate the sine of 7 pi 6. And 7 pi 6 is right here, this red thing, and it's a sine, so it's a y-coordinate. see it's the short leg, and I know that a short leg is 1/2, but because we're in the third quadrant, it will be negative. Now, the cosine of pi 6, here's pi 6 right here, pi 6, and we want the cosine, so we just want this x coordinate. This is the long leg, and the long leg is √3/2. Now, the sine of 5 pi 6, 5 pi 6 is all the way around here. Sine is the y-coordinate, and the y-coordinate is the short leg of the 30, 60, 90 short leg. So that's going to be 1/2, and y's are always positive in that quadrant. Okay, now these are all multiples of pi 4s. This is just disguised 45, 45, 90. So 3 pi 4s right here, this is the sine. Remember that the legs are always √2/2. Now 5 pi over 6, this is the cosine. Cosine is this guy right here. And again, it's √2/2, but because we're in that quadrant, we have to be negative. And 7 pi 4s, that's this, we want the sine. The sine is that y length, and it's going to be √2/2, but because I'm in that quadrant, it'll be negative. Okay, and this is our last one. Sine of pi 6. Here's pi 6. The sine is the y-coordinate, which is the short leg, which is 1/2. 5 pi 6 is right here, and I want the cosine, which is this right here, the x-coordinate. That's the long leg. It'll be √3/2, but remember, it's in the second quadrant, and x's are always negative there. 11 pi 6, this is the sine. This is right here. This is a short leg. A short leg is 1/2. And since it's in the fourth quadrant, it'll be negative.